What about the IUPAC name for this compound? This is a hydrocarbon without any functional groups. It's an alkane, and so functional groups don't come into the decision of how to number the carbons. We have to decide on the numbering according to the alkyl branches. So we need to decide what's the main chain. What are the possibilities? We could have this. Count how many carbons in that. We could have this. How many carbons in that? We could have this. We could have this. And can you see that there are multiple options that are correct? Because we must choose from those which one has the longest chain. But there's not just one answer that's right there. Which of these options will give a branch at the smallest number possible? So, is this carbon 1? Is this carbon 1? Is this carbon 1? This one? Or this one? Try each option and then see which one gives the smallest total when you add up the numbers of the alkyl groups. When you're happy, go on. Which of these options did you choose? So first of all, can you see that any of those main chains that I suggested gives the same number of carbons in the main chain, which is 6. And actually any of them would give the same name. So we can really take any of them, but let's maybe take that one as our main chain. So now we need to decide on the numbering. Let's start from the left. 1, 2, 3, 4, 5, 6. Then let's start from the right. 1, 2, 3, 4, 5, 6. Now let's name each of them, the blue one and the red one, and see which one comes up with the smallest number. So let's first identify the branches. Here we have a methyl branch. Here's another methyl branch. Here we have an ethyl branch. So according to the red naming, we have a methyl on 2 and another methyl on 2. So that could be either B or C, 2,2-dimethyl. And then, according to the red naming, we have an ethyl on 4, which again fits with either B or C. Let's add those up. 2 plus 2 plus 4 equals 8. Now let's go to the blue numbering. According to the blue numbering, we have a methyl on 5. That's 5,5-dimethyl, which is option A. And we have an ethyl on 3. Add those. 3 plus 5 plus 5, that gives us 13. 13 is obviously greater than 8, so the red one wins. So we have eliminated A. So let's take away the blue numbering, which we've shown is incorrect. So now what's the difference between B and C? It's the sequence. Now notice that both of them are actually saying the same thing, but just in a different order. Here we have the 2,2-dimethyl, and there we also have 2,2-dimethyl. But in B, the dimethyl is named first, in C it's second. And then we have 4-ethyl in both. It's just the order of the naming. So how do we decide in which order we should name these? We apply the alphabetical rule. So we need to name the things in alphabetical order. And remember that the prefix di in this case doesn't count as far as the alphabetical naming is concerned. So although D does come before either E or M, it's not relevant to this issue because di doesn't come into the story. So we have to look at ethyl and methyl. Clearly E is before M in the alphabet, and so C is the correct option. 4-ethyl 2,2-dimethyl hexane. Give the IUPAC name for this compound. Pause until you've done that yourself. Notice the presence of the chloride, so this is a haloalkane. Also notice the presence of the branches. When we name haloalkanes, we treat both the halide and the alkyl groups with equal precedence. So we don't give one priority over the other in the naming. We sort of treat them as if they're equal. So here we have the main chain, and when we give the numbering of the main chain, we must give the numbering such that we get the lowest numbers possible, not giving preference either to the alkyl or to the halide groups. So should we start over here? Is that one? Or should we start over there? Is that one? Once you've made that decision, remember that you need to number these carbons to which we have attachments in the name. And then remember we must apply the alphabetical rule in the order in which we mention these substitutions. When you're happy with your name, move on. Is your name one of these? Here we have the main chain, which has 1, 2, 3, 4, 5, 6, 7 carbons, heptane. So we have eliminated A. These two are methyl branches, and here we have a chloro branch. So let's start numbering here at the left. 1, 2, 3, 4, 5, 6, 7. That would give this methyl at 5 and that methyl at 2, 2, 5 methyl, and this chloro at 4, which is option B. Then we start numbering from the right. 1, 2, 3, 4, 5, 6, and 7. That would give the methyl at 3 and 6 and the chloro at 4, which is option C. So how do we decide which of these is right? There are two ways to do that. One is we can add these numbers up. 4 plus 2 plus 5 gives us 11. 4 plus 3 plus 6 gives us 13. 11 is smaller than 13, so B is correct. Another way we can see that is we can start moving from the edges. So we look over here and over here, those are the edges, and we see, is there a substitution? No, so we move in one, move to this position here. From either edge, we've moved in another space. And we see, is there a substitution? Yes, there is. So that's the first substitution that we find when we move in from the edges. And so that one must get the smallest number. So that means we must give it 2, not 6. The red option is right. 4-chloro, 2,5-dimethyl heptane. Notice also that C comes before M in the alphabet. So we must say 4-chloro-2,5-dimethyl heptane, not 2,5-dimethyl 4-chloro. The chloro needs to be mentioned before the methyl. Remember that the di part doesn't come into the issue. What's the IUPAC name for this compound? We notice the functional group here. This is an alkyne, so we need to end in the suffix -ine. We need to have a number before that. So which carbons are those attached to? We need to decide which is the main chain. The main chain has to include that functional group. So something like this or like this is not an option because it doesn't include that functional group. So we must have the functional group. It could be this. How many carbons in that option? It could be that. How many carbons in that option? It could be that. So you choose the one there which has the longest chain. That tells you what kind of ine is it. Is it a hexine or a heptine or an octine or what? Next, after you've got that main chain, then of course you must name the alkyl groups and also name the carbons to which they're attached. Given all that, are you happy with the name that you've given? Once you are, continue with the movie. Is your option given here? Can you see that this here has to be the main chain because that has 1, 2, 3, 4, 5, 6, 7 carbons. Any other option gives only 6. So it has to be heptine. So we've eliminated B. So we have the ine functional group over there. That's present in all the options, but they differ in the number that we give to that. Is it 2 or is it 5? So let's start numbering from the left-hand end. 1, 2, 3, 4, 5, 6, 7. So that's how we get 5 ine. And then we can start numbering from the right. 1, 2, 3, 4, 5, 6, 7. That is how we get 2 ine. Which one's right? We must always number the main chain such that the functional group gets the smallest number. So 5 is not smaller, of course, than 2. So we have eliminated C. Let's get rid of the red numbering, which is not correct. Okay, so here we have an ethyl group that's connected to carbon 4. And here we have a methyl group connected to carbon 5. And we can see that both option A and D has that. The difference between A and D is which order must we do it in. Must we mention the ethyl first or the methyl first? So we make use of the alphabetical rule. E comes before M, so A is the correct option. 4 ethyl, 5 methyl, hept, 2 ine.